All right. Yeah. Hello, everyone. So my name is Priya Donti, and I'm a PhD student joint between the Computer Science Department and the Department of Engineering and Public Policy at Carnegie Mellon. Um, and today I'll be talking a little bit about various ways in which machine learning can be used with high leverage in the fight against climate change. So I probably don't have to convince this audience that climate change is a really pressing issue. Humans are certainly contributing to global climate change, and this has very serious consequences in terms of storms, droughts, fires, flooding, with some of these effects irreversible due to quote unquote climate feedbacks. For instance, as permafrost, frozen soil melts and releases methane, a really potent greenhouse gas that's trapped underneath it. That methane is in the atmosphere for good, and we can't necessarily refreeze the permafrost in order to then bring that methane back down. So what this means is that we really need to act quickly, and for some estimates, to hit a 1.5 degree Celsius global warming target, which is one target that is thought of as, one that would still lead to serious effects, but effects that might be acceptable, we would need net zero greenhouse gas emissions within 30 years. So very quick action is needed here. There are two high-level approaches that are often taken to tackling climate change. One of these is climate change mitigation, so the act of actually reducing greenhouse gas emissions in order to reduce the extent to which climate change actually occurs. And then the second is adaptation, which is given that some amount of climate change is going to occur, how do we as a society become resilient to that? How do we cope with that? And a key point looking at these two approaches is that climate change isn't an on and off switch. In some sense, if we fail to mitigate to some extent, we can adapt, but adaptation is very expensive and is very uncertain, and as a result, we should be acting quickly. So given the urgency of the problem and given the need to act, about a year and a half ago, a number of people from the machine learning community started to wonder how exactly they could contribute to tackling climate change. And on the flip side, a number of people from the climate change community started to see a lot of data being available through remote sensing, through sensors on the power grid, et cetera, and started to wonder, can we start leveraging machine learning to give us insights from this data? And so about a year and a half ago, a group of us basically sat down and started to write this paper called Tackling Climate Change with Machine Learning. It was meant to be a 20-page paper initially, but this problem is very large. So it's a 100-page paper that details basically various ways in which machine learning can be used with high leverage for climate change mitigation and adaptation. So just to walk through maybe quickly the table of contents here. So the way the paper is organized for those interested in checking it out is the kind of individual sections or chapters are organized by different areas in which you may want to employ climate change mitigation or adaptation strategies. So the first column there is are ways or places in which you would try to reduce greenhouse gas emissions. And the second column contains a combination of ways that you would adapt to climate change and also kind of overarching tools like tools for action, education, or finance that can help us to implement mitigation or adaptation strategies. We also kind of take a couple of major areas of machine learning that a lot of the community thinks about, and we attempt to provide a mapping here to show sort of which techniques can have application in which areas. So given that the talk is short, I obviously will not be able to go through all of these, but I wanted to share a couple of illustrative examples that I thought were indicative both of a variety of different places in terms of the climate side that machine learning can plug in, and also indicative of various kinds of things that machine learning can do. So unsurprisingly, one of these things is forecasting. So as electricity system operators try to balance electric grids, they have to make sure that the amount of supply that is fed into the power grid is equal to the amount of consumption of electricity from the power grid at any given time. And as you start to use more energy like solar and wind, which depends on how much the sun is shining and how much the wind is blowing, this problem becomes increasingly challenging. And so there's really a need to somehow get more accurate forecasts of solar and wind power in order to help balance the grid. So machine learning can help by providing short and medium-term forecasts of both electricity supply and also actually electricity demand. And this is usually done using a combination of historical data. For instance, what was the solar production yesterday? What was electricity demand yesterday? And also increasingly information from physics models that are run to make these predictions, as well as image and video data. There's some work that looks at, for example, putting a camera pointing upwards next to a solar panel so that it can track the clouds going across the sky. And this way we can predict basically whether a cloud will shade a solar panel at a given time. And while forecasting might seem like a topic that is, that is very common for machine learning, there are some particularly important considerations that come up when using forecasting and machine learning-based forecasts in a climate change context or in a decision-making context where, for example, you're giving a forecast to an electricity system operator. One of these is that you want to start incorporating system physics and goals. So for an electricity system in particular, we do have knowledge of how an electricity system works. There are hopefully some electrical engineers in this audience who definitely can tell you how an electric grid works. And so it's very important that we don't throw that knowledge away when constructing forecasts. Or similarly for solar power, we have meteorologists, physicists who can tell you how solar insolation works. And so it's very important that machine learning techniques, through techniques such as hybrid physical modeling, start to incorporate these physics and other goals of the system alongside the data that they're taking in. Similarly, we want to make sure that these forecasts are characterizing uncertainty or are interpretable so that electricity system operators can use them. So there are lots of considerations like these that come up when actually starting to use forecasts in a real-world context. And forecasting is not a problem just limited to electricity systems and climate change. It comes up across, for example, trying to predict extreme weather events like hurricanes that are caused by climate change so a city can adapt, or trying to predict crop yields in a field so that agricultures can better adapt to the effects of climate change. Am I getting a time warning here? All right. So I will breeze through other applications, but some other applications include things like gathering infrastructure data, so using satellite imagery to create counts of buildings or understand the attributes of buildings. And to tie back to the previous talk, there's also been work on, for example, transforming telecom data into estimates of electricity demand data. So basically, machine learning can help transform kinds of data that we might use for one purpose into kinds of data that we may use for another. Precision agriculture is another kind of application where basically currently farms are managed growing one crop across a very large field. And this can be very detrimental to the soil, which can then basically degrade the soil, cause us to use more nitrogen-based fertilizers that take a lot of carbon dioxide emissions to produce, and can also disrupt microorganisms in the soil that actually sequester carbon dioxide. So machine learning can provide controls, like robotic controls, that can allow us to actually grow more than one type of crop on a larger kind of land, and that way scale basically techniques that allow us to use practices that are more friendly to the land. And then finally, another theme that comes up is basically the idea that we have a lot of very complex physical simulations in climate change contexts, things like climate modeling or running energy scheduling models. And machine learning has been used to approximate all or parts of these models, for instance, by learning a cheaper model based on the inputs and outputs of these models. And also to help gather data as inputs to these models that we may not have. For example, ice is one of the largest forms of uncertainty in climate models, and so gathering data about ice sheets can be very useful here. That's it. There are, of course, a lot of themes in the paper that I didn't get to, but I would encourage checking it out. And if you are enjoying this digital conference and would like more digital conferencing, we'll be holding a workshop from the 26th to the 30th at iClear, and the live stream will be free on the website posted on this slide. So I welcome any questions.
Yeah, Priya, thank you so much, Priya, for this very nice overview of using machine learning for tackling climate change. And due to the time limits, we won't have time for additional questions. But again, thank you for the very nice talk.